Welcome to Bodhana. If you are new to here, I'm Dr. Ramesh. As part of lecture series, in this video, I'm going to discuss about the Applied Physics Chapter 2, Semiconductor Devices and its importance. By seeing this, a small component, this one, it creates wonders in the electronic gadgets. Very small devices, but the applications are tremendous. As we know that the solids are classified conductors, semiconductors and insulator. But when you take in the application point of view, the semiconductor grab the complete attention of the electronic gadgets or the electronic industry as compared to the conductors and insulator. Even the conductivity is more for the conductors, even the complete blocking of conductivity in the insulator, but application point of view, semiconductor play a big role, very small. How it is possible? Because we can tune the properties of semiconductor based on the requirement. In this process, semiconductors are classified in different ways: intrinsic, extrinsic, elemental compound, direct and indirect band gap semiconductors, and their applications are not at all same. Even this is the semiconductor, if this is a semiconductor, it can able to produce the light, even it can able to produce the current by using the light. That is nothing but the principles are completely different, but the same material is not suitable for different applications. Based on the requirement that we are using the different kinds of materials, especially material point of view, semiconductor has different applications: solar cell, LED, laser diode, detector, sensors, many more we are constructing by using the semiconductors. Coming to the topics related to the chapter 2, it starts with the intrinsic versus extrinsic. As we know that, just we discussed, the properties are tuned. Intrinsic means pure and extrinsic means impure. Why we are adding some impure content? To alter the properties of the semiconductor, we are adding some more impurity concentration to the pure semiconductor. Then obviously impure or extrinsic semiconductor play a big role, especially in the application point of view, compared to the intrinsic or pure semiconductor. This part we are discussing as introduction to the semiconductors. And then Hall effect. What happened when the semiconductor is placed inside the transverse magnetic field? How we can calculate the charge carriers, how many charge carriers are present, whether it is electrons or the holes, whether it is a p-type or n-type, mobility. All these factors can able to measure by using the Hall effect, which is one of the most important topic related to the semiconductors. Even we have laboratory experiment too. And then coming to the next scenario, direct and indirect band gap semiconductor. Generally, before going to this particular topic, we need to discuss about the elemental semiconductor. Element means like a single element, either germanium or the silicon, covalent banded nature, valency 4, all these related to these semiconductors. Compound means mixing of two, gallium arsenic, indium phosphorus, gallium, aluminum arsenic, all these materials are under the compound semiconductor. Direct band gap is generally used for the light production. Indirect gap semiconductors are used for the heat production. So there are different, for example, when we take in the LED, obviously according to the general topic, LED is the light emitting. Then obviously we need to use the direct band gap semiconductor. So compound semiconductors are example for the direct band gap. Elemental semiconductors are example for the indirect band gap semiconductors. This part we need to discuss. And then starts with the what happened P, that is a trivalent impurity is added to the pure semiconductor, then it becomes like a p-type because holes are the majority charge carriers. Similarly, n-type, we are adding the pentavalent impurity to the semiconductor to increase the electrons as the concentration in that particular semiconductor, then it become like N. There are different scenarios, there are different applications for the P and N. Then what will happen if I combine both the P and N together? Obviously, according to the diffusion concentration, majority holes from the P side is want to move towards the N side and majority electrons want to move towards the P side. But it's not that much easy. There is some concept in the construction and working of PN junction diode. So this PN junction diode is act like a switch. If it is in forward bias, what is the meaning of biasing? External support. When we given the battery connection to the PN junction diode, the positive to the P side and to the negative is terminal is to the N side, then it called as forward bias, and the opposite reverse bias. Generally PN junction diode only operate in the forward bias. By knowing the IV characteristics, then it may give the clear idea about the how the PN junction diode operate only in forward bias. It act like an on switch, and in case of reverse bias it is like an off switch. So the PN junction diode is not suitable for the reverse bias mode. To overcome that problem, we are using the GINA diode. The GINA diode is similar to the PN junction diode, except doping concentration is higher in case of GINA diode as compared to the PN junction diode. In this part, we are discussing about the importance of PN junction diode under forward bias and the reverse bias, GINA diode and its reverse bias characteristics. And then BJT, bipolar junction transistor. Here you can see the three terminal. Here you can see three terminals: emitter, base, collector. Three bipolar by two junctions. In case of PN junction diode, one is P and is only one junction. But whereas when you take in the three components, P, N and the P, in between P and N is the one junction, N and P another junction. This is called as bipolar junction devices. It's not only P and P, we can make it as like a NPN. And its application is the one part related to the chapter 2. In addition, applications of the PN junction diode. The importance of semiconductor is it can be diodes. It can be used in forward bias for one application, reverse bias is another application, and even open bias is also another kind of application. For example, when we take in the solar cell, nothing like it's like a light is converted like a charge carrier. This is one kind of application. LED, light is emitting. It is in forward bias because electrons and holes are combined together to produce the light. Because electron in the conduction band, hole is in the valency band, the difference amount of energy is released in the form of photons, that too in the form of light. That's what we are using the direct bandgap semiconductors. So LED, solar cell, both are constructed by using the semiconductor, but one is operated under one bias condition, another is operated in the another bias conditions. And coming to the other part of the syllabus, pin and avalanche photodiode. It's like a detector, it's like a sensor. Mostly in industries, counting devices, when the like a gadgets are generated by the machineries, that components is not counted by the human beings. We are using the sensor. In that particular case, we are using the photo detectors. That is constructed by using the PIN or avalanche photodiode. It is operated in reverse bias. Very minute current is enough to operate the reverse bias mode. So finally, when you compare to the conductors and insulators, semiconductor grab the attention of the complete electron industry. Without semiconductor, we can't imagine the world like this. That much importance is there, especially for the semiconductor. It has vast application and variety of devices based on the requirement. That's what semiconductor is one of the most important topic for engineering graduates. Thank you.